Okay, this side of your math notes is on reading data displays, and we're just going to review a few data displays that you probably are comfortable with from lower school, and we'll talk about a couple that are newer to us that we kind of introduced at the beginning of school. So we didn't really talk about them. So this is to formalize those ideas. So a bar graph, you guys are probably familiar with from lower school. It shows horizontal or vertical bars that show data in categories. It's good for comparing quantities in categories. Again, sorry about the double blanks there. And it allows you for a quick visual scan of data. The limitations of bar graphs is that it's not as good for most numerical data because most number data has so many different numbers that you'd have to make a bar for each of those. And so it's not quite as good for number data. So we'll talk about a solution for that in a minute. So Venn diagrams, as a review, are these overlapping circles that show us a visual display of the relationships of, I don't remember what I created this for, but I think we're going to go with the word categories here. Again, Venn diagrams are really more for comparing data that has categories and seeing any relationships between those. It's good for showing overlaps and differences of data groups. So we can see there's cats, dogs, and then must be both cats and dogs, and then neither cats or dogs based on the fact that this 3 people are outside of the circle. And the limitations are that the totals of each set aren't very clear. So for example, 17 people have cats in the diagram above, and if we were to look at it with a bar graph, we'd see a lot of cats. I guess we'd also see a lot of dogs, 16 dogs. But we have to remember that this middle category needs to be added to each of those separate circles because it's in each of those sets. So it's kind of a limitation. There's some calculation involved, so it's not immediately like as visually helpful. Scatter plots. A description of a scatter plot. Let's see, what have we got here? We've got, before we do a description, let's look at this up more closely. So we've got visitors. That must be the number of visitors, and this is a title, beach visitors, and then average daily temperature. So kind of looking at, it's a lower temperature here, and the visitors are fewer, but the higher the temperatures go, we can start to see more people are going to the beach in these higher temperatures. So scatter plots are really nice for looking for a relationship or a lack of a relationship between data points. So the description, plotted points show 2 pieces of data. Just by plotting a point here, I'm showing that the average daily temperature was 82. Sorry, you can't see that. About 82, and the number of visitors was about like between 75 and 150, maybe like 90. But we're able to show 2 pieces of data with each dot, which is pretty effective. One type of data is shown on the horizontal x-axis, and that's labeled here, so this is average daily temperatures. And one type of data is shown on the vertical axis, right here, visitors. This is really important when we're making scatter plots to label our axes so that people know what they're looking at. It's good for showing the relationship. Again, a double emphasis here, or lack of relationship. So it might be that the dots don't show a pattern. Right here, we can see really clearly this pattern, this trend of the higher temperatures. As temperatures go up, the visitors also go up, and it does seem likely that there is a strong relationship, or bonus word, correlation, is this bonus word here, between the temperature and the number of visitors. Higher temperatures are likely to have higher numbers of visitors, and we'd call that positive correlation if both numbers go up. Limitations of this are that it's not as easy to read if you are more interested in just one set of data. So if you're really just interested in the temperature, you don't really need to worry about beach visitors, and a scatter plot's going to be more complex to make. Or maybe you're just worried about the visitors and you really don't care if it relates to the temperature of the day. Then you might as well just do a line graph that shows the number of visitors over time. So that's a scatter plot. We'll probably do more with scatter plots and do a different math notes just to explore this idea of correlation as you guys are working on a POW coming up. So more on that to come. Let's look at histograms finally, because we've been talking about this in math class. So frequency, let's look at the graph first. This is titled Frequency Distribution of Height of 25 Students. And it's got the data source there, which is helpful. And then it's got frequency on the y-axis and height in inches displayed on the x-axis. And then you can see that there's a dash between numbers, so like 54 to 56, 56 to 58, 58 to 60. And these ranges are, I'm noticing, 2 to 3 numbers. And it looks like a bar graph because it's very similar to a bar graph. But a histogram solves the problem of needing one bar for each number, because you can group numbers together into smaller groups and then say anything between these numbers will go in this category. So anything between 62 and 64 inches will go here. So the description bars, usually vertical, show data within ranges or intervals. So not just one number, but 2 to 3 numbers here. It's good for quantitative. Quantitative means numerical, number-based data with consistent ranges. And this idea is really important. Those consistent ranges need to have equal size so that this is an accurate picture of the distribution. If we had one column here that included 10 numbers, then we'd probably have a much bigger bar, and it would visually be misleading because people would think, oh wow, like all of these people are within this range, and they might not notice the detail of the fact that that range is bigger than the others or smaller. You want to make sure intervals each have the same range, so let's check here. 58 to 60, 60 to 62, 62 to 64, they're going up by 2s, but I do want to comment on the fact that one challenge of the way they have labeled this is the fact that they are using the same number in each of the columns. So if I had a height of 60 inches, it's unclear which column I would put myself in. And I think that we need to make our histograms a little bit differently here so that it's more clear. So if your data, if you were working with heights, you might want to define this more clearly, 58 to 59, and then 60 to 61, and then 62 to 63, if you're doing intervals that have 2. If you're doing intervals that have 3, same thing. You want to make sure that the difference between those two numbers is the same size, but I don't recommend having the same number in 2 categories because that can be really confusing for people who are reading that data and confusing to people who are making the data too. So limitations, exact data can't be seen. There's only a range of responses. And the other limitation I would say is a challenge is that interval size can be a little tricky to figure out. We'll be practicing this week in class, and hopefully we'll feel a little bit more comfortable with it before next week's quiz to figure out. Okay, thank you. I hope this was helpful.